Part 9 of the Corvette build. We're making progress. It's been a while since I did a video. I've been doing a lot of stuff like cleaning up parts and painting. As you can see, that's just the front end parts. I've got the rear bumper apart, and that's going to be coming up here soon. But I have a lot of stuff going on at the moment on the car, so I'm going to apologize that I'm going to skip around a bit on some stuff, but let's get started. There's a difference in the mounting holes in the front part of a frame from a 73 to a 76. So what I did, I took a piece of paper and I traced the pattern of the 76 chassis, and then I'm going to put it up against the 73 so I can see the difference. Okay, so if we line this up, we can see the two holes that have the nuts welded in are in the same locations, but the bottom left and the top right, you can see they're just off by a little bit. So I'm going to have to open those holes up to accept the 76 front part of the frame. So I took the template, took a razor blade, and I cut out the two holes that need to be opened up. Lined up these two holes in the outline and traced that onto the frame. I went out and measured, and those holes are actually a 5/8 oblong hole. There's a lot of slop there because the hardware that's used is only 1/2 inch. So I don't think we have to be super precise on where we get these holes. It's not the prettiest due to intersecting the other holes, but you can see here's the hardware. And you can see how much slop it has anyway. And it uses a big washer. I think it'll be okay. I'm also thinking about boxing these rails in to get more strength, since this has the big Ride-Tech muscle bar on it. It's probably going to flex a lot. I bought a low-car throttle cable, 36 inch for the LS. The problem is square hole. And it's round. So what I did, I made two plates, one for the outside and one for the inside. And I'm going to rivet those on, that way they'll be sandwiched and support the cable. Now we'll have to modify the throttle pedal. This is the low car end. As you can see, it really needs to be faced that way and have a smaller hole. So we're going to modify it. I have multiple gas pedals, and it's interesting. This is the stock one out of my 76. And I have these. They're much bigger. The rods are exactly the same. Well, the hole at the top has a slit on one. This one has just a regular bracket. This one has the long bracket like my 76, and what appears to be some kind of throttle position sensor. Didn't have one of those in my car. So I don't know why these had bigger pedals, but some of them did for some reason. Okay, there we go. We twisted the end of the throttle pedal, we welded the hole shut and drilled appropriate size hole. So now, that fits, and there's not a lot of slop. Now I won't know if I have this bent to where I have enough pedal travel until I get the throttle cable hooked up to the throttle body and see if it will pull it fully open or not. Time to start work on the core support. This is the core support out of the 76. and you can see the front. This would be if you're looking from the front of the car, so where the AC condenser would sit, and you can see it's completely rotted out. The part where the radiator sits, still in good condition. So, me being the cheap person I am, I don't want to spend $400 for a new one, so I'm going to try to repair this. We'll see how it goes. Okay, I've got one side of the core support cleaned up, all the rusty metal cut out. So to make the new piece, there's a step here. I want to try to replicate that. I made a test piece, which turned out pretty good. It's a little bit thinner metal than what I'm going to be using. So we'll see. What I'm going to do, have this bar, and I already bent a piece of 16 gauge into a 90 by clamping it to the edge of the bench and hammering it over. But I'm going to put it on the edge of this bar, and then using another tool, clamp it down and drive the shape into it. We'll see how it works. Alright, so let's be honest here. This looks like hammered dog crap, but I'm learning a lot. I don't have any schooling on how to do any metal fabrication, so I just kind of learned along the way. I got the step that I wanted in it, and I learned as you hammer, it will draw the metal in certain directions. So, I mean, that's how you learn. You go through and you hammer on things and see how they move. Now, it is super strong. Adding that step in there, you cannot move this metal anymore. So it's functional, and it's going to be hidden under the car, so I think it'll work just fine. I finished the repair on the core support. Turned out okay. Not the prettiest in the world, but it'll be functional. One thing I am going to do is I'm going to spray the inside of it with the Eastwood internal frame coating. At the top, these holes are big enough that I can feed this all about halfway down the sides. But there's no holes in the bottom. So I went ahead, I drill, I can't see, a 1/4 inch hole in each corner so that I can feed this hose all the way up inside and coat the entire inside of it. I need to block off these two holes because the only thing that's going to be going through them now is one vacuum line that goes out to the fresh air valve and the supply line that goes to the heater controls. So I made these two plates. We're going to rivet them in place. We're going to coat the back with RTV and then rivet them in place. And I put rubber grommets in there that are the right size for the vacuum hoses so they'll be sealed. Started working on filling in the tunnel around the shifter. I think this shifter is going to be in a very good location. So what I did took some measurements, and I made a plate that fills in mostly around the shifter. One thing I did have a problem, this is still touching or almost touching here, so I've marked this, and I'll take the body back off the chassis, and I'm going to try to bend that up to match the radius that I've put in this plate to clear the transmission. And then I'm going to weld that in. I also was trying to find a lower shift boot, and this part of the shifter is oval shaped, and I noticed that the early C3 shift boot has a similar shape in its pleats, so I'm going to order one of those and see if I can cut it to fit around that. Okay, I've got the hole filled back in, and I've test fit it back on the chassis. I had to pound it out a little bit more, but that's looking pretty good. While I was in here, I went and got the seam sealer out and sealed around the feed throughs for the battery and all the studs. So next I have to wait on the lower shift boot to get here so that I could fit it and get the holes drilled, and then we'll do a coat of Pour 15 and finish it off. You get started on installing the clutch and the hydraulic system. I bought all this from Modern Driveline. They are selling the bowler kit for the C3, which uses this billet bracket. I had to purchase the frame bracket since this is an automatic car. It doesn't have this bracket on the chassis, which is used to bolt to. But it comes with bracket, reservoir, the master cylinder, the rod to connect to the pedal stop. I talked with the customer service at Modern Driveline, and they got me all the fittings, got me set up with all the fittings to plug directly into the factory throwout bearing in the TR6060. Kit comes with steel braided lines as well. Also went ahead and had them throw in the ARP flywheel bolts. The clutch, this is a Kevlar material clutch, billet aluminum flywheel, and this is Modern Driveline's brand of clutch. I believe they call it Superior, but they spec'd all this for me. The customer service was really good. So I already pulled the old pilot bearing. It had the small pilot bearing down in the inside. The TR6060 uses the big throwout bearing for the outside. I keep seeing these videos where people stuff bread down inside the pilot bearing and then use a punch to get the old pilot bearing out. But you see that plug in there? And the LS cranks, that's like a freeze plug, but it's for the oil galleys in the crank. So I don't recommend trying your little bread trick. Get the correct puller. You can go to Harbor Freight and get it for 30 bucks and pull the pilot bearing. The next step is to figure out where the manual clutch bracket needs to be welded onto the chassis, since this was an automatic car. The automatics come with this plate. I already took the screws out. Pop that off, and that's the hole where the clutch goes through, where the clutch rod goes through. I bought the boot that goes around it. So now I'll put this all together and get it lined up, and we'll get this bracket welded onto the chassis. I screwed around with the location of it until The rod was pretty well centered in the hole, and I have full actuation. What I did is I clamped it. It's not super secure, but I clamped the whole assembly down to the frame and then reached inside and pulled the pedal, and it has full travel and still has adjustment. So I think I've got a pretty good location. One thing I did determine, these lines are for an automatic brake lines. I don't know if they're different for a manual, but they definitely run right where that bracket needs to be welded, so I'm gonna have to bend them out of the way. But now we'll take it back apart. I have it marked where it goes on the chassis, and we'll get that welded on. All right, I only cleaned up here and on the other side because I needed the marks to be able to line it up still, and I've got it clamped in place. So I'm gonna tack it in, and then I'll come back with like a die grinder and remove the paint in these areas so I can weld that in also. One thing that might help somebody, I noticed that this lines up pretty much straight. I'm assuming because there's a shaft that comes across here that for the factory setup. So yeah. So apparently the manual cars had a pedal stop, but since this was an automatic car, there isn't one there, and there's no holes to reference. So the bowler kit comes with a pedal stop that you have to install. So I'm placing it on the floor, and I'm lining it up with the pedal, and then I just marked it with Sharpie. I have to drill 3 holes, 2 for the bolts and another one for this bolt to go all the way through. So we'll get that drilled out. Okay, I got the stop installed. As you can see, the pedal hits it directly, and it's adjustable. Screw it in or out, but we'll adjust that once we have the entire system set up. All right, the bracket's welded in and painted. As you can see, so the brake line used to be tied down in that hole back there, and I flipped that bracket around, bent the lines out, and drilled a new hole here closer to the inside, and everything still fits okay. So that'll allow for us to bolt the bracket and the master cylinder for the clutch. One of the things that has to be done on these gas tanks is you have to add a vent, and this is a rollover valve also. So I went and I used these existing holes and I bent this bracket up. This is just mock-up so far. Something you want to be careful of is you don't want this hose to dip down to where it can get full of fuel. So this is about, I don't like that the vent comes out and points down, but this is as close as I can get it, and it still has some slight downward, so it shouldn't trap fuel in there and should still be able to vent. So now we'll get this bracket cleaned up. We'll round off the corners, clean it, make it look nice, and paint it. So I need to mount the reservoir for the hydraulic clutch, and this right here looks to be about the only spot where it'll fit nice and still be able to access it. The hose can get to the bottom, and it's within reach of the master cylinder. Nice part is Bowler sends you a template, so I'm going to tape that on there and then drill out the holes. I got the factory 4-speed shift boot in, and I had to laugh at how small it was. I didn't realize that this shift boot was that small. It doesn't even cover the opening. So I'm going to return that, and I've ordered a 4th gen F-body boot, which I could find the measurements, and it should cover that hole. So I was working on installing the clutch, and one of the most important things that you can do is measure the distance between the throwout bearing and the clutch itself to make sure it's not that you're not going to be putting any pressure on the clutch. That'll cause the clutch to fail prematurely. So this is the factory throwout bearing out of a 5th gen Camaro that came with this transmission that I bought used. Everyone on the internet says that this should work just fine. Well, when I put this together, measuring crossed here with the throwout bearing completely compressed, measure the distance to the face of the bell housing here, and then across the fingers of the clutch to the bell housing on the motor, and I ended up with 107 thousandths of interference, which means when this was bolted together, the throwout bearing fully compressed would be pushing in on the clutch, which is going to take pressure off the plate, off the disc, and cause it to fail prematurely. So I talked to the guys at Modern Driveline where I bought the clutch from and the flywheel, and we took some more measurements and we figured out that the 5th gen Camaro throwout bearing is 3.5 inches when fully compressed for the TR6060. This is the throwout bearing out of a 4th gen Camaro T56. When it's fully compressed, it's only 2.5 inches. So you can use either one in here in the same bolt pattern, but now the problem is now it's too short. Now it won't even touch the clutch. So taking the measurements and the calculations, they also gave me a 625 thousandths thick shim to put behind it, which should set up the measurements correctly. You have to have at least 1/2 inch compression on the throwout bearing, but you also have to have enough travel left in it so that as the clutch wears, it's going to get further away. The fingers will go further away from, is that right? Sorry. The fingers will come closer to the throwout bearing, so you have to have enough room that as the clutch wears, that you still have room so it doesn't compress the clutch. So we'll get to putting this together, and then we'll do after I install this, I will take all the measurements again and make sure everything's working out. Okay, so apparently math is hard, and we were wrong on the last spacer. I actually ended up having to send that back and get 2 thinner spacers, which equal more. Hold on. I had to get 2 400 thousandths spacers, which stacked together equals 800 thousandths, because I wasn't getting enough compression on the throwout. I was only getting, what was it, 0.371, and these require a minimum of 1/2 inch because you're going to need 40 thousandths worth of travel to compress, to push the clutch. So I just measured these, it with these stacked in there, and we're just over 1/2 inch, so we're perfect. So now we can put it together. I do have to go get different hardware though, because this is an abnormal stack, so the hardware that comes with it isn't going to work, but I'll grab those from the hardware store and we'll get this put together. So there you go. I repaired this pretty much rusted out core support and saved myself quite a bit of money. These things are expensive, like $400. So I think it turned out pretty well. We did a little bit of work on the tunnel. We got that filled in, got the shifter fitting. What I didn't get to is telling you about the 4th gen shift boot. That's we'll fit that in a later video, but I think that's gonna fill the hole nice. This is actually metal under here, so you can bend it and shape it. As you can see, I got the seat order came in. They are not attached. Turns out you can't use the Corvette mounting brackets because it sets the top of the seat right about here, and you're looking right at the windshield. So these are actually just sitting on the floor on the mounting bolts. So they'll go just a little bit lower. They're gonna have to be mounted directly to the floor to have enough room in the car, but we'll do that in a later video. Also got some wiring going on. Got that rear bumper. More of that in the next video also. And then we got the clutch installed. Showed you that and how to measure throwout bearing. So next time the chassis comes off the body, we should be putting the motor back in for the last time. All right. Thanks for watching.